The math of vortex sheets.
So, to see how engineers actually model this highly complex airflow, I want you to imagine a sequence. Picture a single vortex of a specific strength, and now imagine it being repeatedly subdivided into smaller and smaller vortices, distributed evenly all along a line segment.
Now, if you push this subdivision process to its absolute limit, you get a full vortex sheet. It's almost like a giant puzzle. By laying all of those microscopic vortices side by side right along the curve of a wing, we get this perfect mathematical representation of the airflow boundary directly at the surface.
And looking at the math, you can see the tangential velocity jump across this sheet equals a constant, gamma, at all points. Okay, I know, it looks a little intimidating on the surface, but this equation actually completely demystifies lift. By calculating the difference in velocity just above and below this vortex sheet, engineers can pinpoint the exact pressure differential. So right there, that is the precise mathematical proof of how shape and fluid dynamics keep a massive plane up in the sky.
Let's wrap up our sections with Section 5, How Jet Engines Work.
Because, let's be real, without forward momentum, you don't get any of that beautiful lift. Thrust relies entirely on Newton's third law, and it's executed through a highly precise sequence. First, the intake draws air in. Then, the compressor violently squeezes it, skyrocketing the air density. After that, it's mixed with fuel and ignited in combustion. All those rapidly expanding gases spin a turbine, and finally, the nozzle blasts this gas out as high-speed exhaust. That violent backward flow, that's the action. And the forward thrust of the aircraft, that's your reaction.
We've journeyed all the way from debunking middle school myths to the absolute cutting edge of fluid dynamics today. It's honestly incredible to realize that every single time you look up at an aircraft flying overhead, it's these exact physical laws working together in perfect harmony. So as we wrap up this explainer, I want to leave you with this thought. How will mastering these incredibly precise aerodynamic realities reshape the future of high-speed flight? Like, what radical new designs are going to emerge when engineers push this math to its absolute limits? It's a lot to think about. Until next time, keep questioning what you think you know.